A linear model is not going to be helpful here because we require a model that is capable of portraying a nonlinear relationship. Now, there are several options for accomplishing this. We might use k-nearest neighbors, or we might consider using neural networks, or we might consider using a kernel density estimation at each point of elapsed time. In fact, that might be where we'd go if we did not get anywhere using any other features. To make use of our feature set, let's attempt to use a k-nearest neighbors fit. Before we jump into fitting our k-nearest neighbors model, let's talk briefly about preparing our data points. So let's talk briefly about how we collect a series of training points that contain intertweet time, tweet length, elapsed time, and mention distance. So recall in the original dataset, we're given points such as T1 and T2, representing two succeeding tweets. The amount of time taken between them is considered the intertweet time. But we want something that's more fine-grained than this. What we're looking for is, given an amount of time that has elapsed since the previous tweet, how much more time do we have to go until the next one? We're going to produce that information for each pair of given points. For example, if this is the intertweet time between two given tweets, we can choose a point here and consider the beginning to that point to be elapsed time, and that point to the end to be the time to go. And we can consider putting that marker at many points, giving us many values of delta S and P. This gives us many values of elapsed time and time to go. And for each one of those points, we still know the length of the previous tweet and the number of seconds that has elapsed since the last time this person has been mentioned. In this way, we construct our training points. So, after constructing our training points in this way, we get a total of 1,381,258 points. And we will split those points into 70% training and 30% test. Let's go ahead and fit the data and perform some steps of validation and measure the performance of using k-nearest neighbors.